Hello and welcome to Web Math Academy, where today we're going to dive a little deeper into the subject of normal distributions. We're going to use the data set that I have labeled here. It's the same one I've used in our previous tutorials. It's the on-time arrival percentage of flights into the top 30 airports in the US, ranging from a high of 88.45% in Honolulu down to 66.54% in Newark, New Jersey. I've already entered this data into our ti-nspire CAS calculator, although I've done it in reverse order, not that that matters. What does matter is that we label the data, and I've already done it up here. You just click on that button, type in what you want to label it, hit enter, and you're good to go. Now what we would like to know is this data a normal distribution? And there are several tests we can use to find that out. First, we look at its histogram from our previous tutorial. We ask, is it symmetric, and is it mound-shaped or bell-shaped? In this case, the answer is yes to both. It's a roughly symmetric graph, and it's roughly mound-shaped. To go into a little more detail, we can look and ask, are the mean and the median of this distribution similar? Now, the mean is easy to compute. It's simply the average, which is the sum of all values divided by the number of values. This would be, in this case, 88.45 plus 85.70, blah, 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 down to 65.54. Add all those together, divide by 30, and you get the answer of 79.505. That's the mean. The median is even simpler to compute. It is actually just the middle value where the number of data points above is equal to the number of data points below. In this example, the median number would be the average of the two closest middle numbers, 80.21 and 80.27, giving a median of 80.24. So, are the mean and median similar? Well, yes, they are less than 1% apart. So, our distribution passes that test also. Finally, let's look at the normal probability chart and find out whether it is linear. To plot this, we'll use our ti-nspire CAS graphing calculator. To do that, you go to the On button, click Graphs, that's the pink icon, and then click to add variable on the bottom, and we're going to type on time. Actually, it already put that in for us, but that's the variable that you remember we had assigned up above. Click that, and it comes up with a dot plot, which is similar to a histogram. But we want a normal distribution probability, so we will click on Menu, Plot Type, Normal Probability Plot. And that's our result. As you can see, our result is very linear. This is a normal distribution. You can also see that there's an outlier, a data point that kind of doesn't fit, and that would be our lowest number here, 66.54. That was the arrival percentage in Newark, which is horrible. The other thing to get from this is that the equation of this line actually uses our mean, 79.505, and what we'll determine later, our standard deviation, 4.35787. Those are the only two values needed to determine this normal probability distribution. Now on to computing the standard deviation, which, as we mentioned, is a measure of how variable the data is. Larger standard deviations would mean the data is more scattered. Smaller standard deviations would mean the data comes closer to the mean, it's closer to each other. For example, if all the data points were actually the same, say 10, 10, 10, and 10, the standard deviation would actually be 0. Remember from our previous tutorial that the standard deviation can be computed as the sum of the mean of the data point minus the mean squared divided by n minus 1. Now x bar, which is the symbol used for the mean, is what we had just determined up above. Now let's check this table to see how this works. Now here's our table again showing the on-time arrival percentages, and this time I have put in the computations for x minus x bar. That's the x, the data value, such as 88.45, minus the mean of 79.51. That gives us an answer of 8.94. If we square that, we get 79.92. So I've computed these values all the way through. Then if we take the sum of all of the x minus x bar squared values, you'll come up with a value of 550.74. Then if you divide that by n minus 1, which remember n is the total number of values, in this case 30, minus 1 would be 29, so we're going to divide the total 550.74 divided by 29, we're going to get 18.99. And if we take the square root of that, according to our calculations, is the standard deviation, and we get 4.357872. We can get that same result from Excel using the formula down below here, equals standard deviation dot s from the quantity C3 to C32 on your Excel spreadsheet, and you get the same answer, 4.3578 to the 4th decimal place. Finally, the normal distribution or bell curve can actually be plotted itself using the following equation, y equals, and there's that mess. Piece of cake though, right? The important point to take away from this complex equation is that it only depends on two things: the Greek letter mu, which is used to represent the mean, and sigma, which is used to represent the standard deviation. Now we know both those values here, so we could technically construct the normal distribution from scratch. If we do, we come up with the curve as below, which shows the mean and the standard deviation. Now if we have these values, we can also determine other parameters, including the probabilities of obtaining a certain value or areas underneath the bell curve using our ti-nspire calculator, but this will be a learning tool for another day.